What's up, junior mathematicians? We're taking a look today at section 8.1 in math analysis, which is a review of some right triangle trig, which is something you've seen before back in geometry, but it's something good that we like. It's a good topic to revisit for the rest of the unit. And the right triangle trig that you guys are familiar with is SOHCAHTOA, right? The story of the Indian princess that had to cross a river, right triangle stuff happened, and I don't really remember the whole story, but it's cute, and I know that you guys know it from geometry. And here are the relationships that we're talking about, where the whole SOHCAHTOA relationship comes from, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, or SOHCAHTOA. And then we also have on the right side the reciprocal functions, and obviously it's just the reciprocal. So the reciprocal to sine would be cosecant, which is the reciprocal of sine. Instead of opposite over hypotenuse, we got hypotenuse over opposite. And so we've been looking at these relationships, and specifically their values on the chart for 30, 45, and 60 degrees. Remember, we looked at the unit circle and did some really fun stuff with that. And there's a couple relationships on here that I hinted to earlier, but I really want to point out now, which is, check this out. You got sine of 30 degrees is a half, and that happens to match cosine of 60 degrees. So let's just kind of get this down. We see that sine of 30 is equal to cosine of 60 degrees. Okay, and then, yeah, you know, we can spot some other ones here. Let's see, we've got the sine of 60 is equal to cosine 30. So the sine of 60 degrees is equal to cosine 30. So it looks like we've got something going on there with sine and cosine. Let's take a look at the other parts of the table here. Let's look at tangent. Tangent. Let's get rid of some of these first. And then let's look at tangent, square root 3 over 3. Where else do I see that? Looks like over here, tangent 30 is square root 3 over 3. Well, cotangent 60 is square root 3 over 3. So I've got that relationship as well, that tangent 30 is equal to cotangent 60. And just looking at the 30 and 60 degrees measurements, it looks like we have this relationship going on between sine, cosine, and then tangent and cotangent. Also cosecant and secant as well, right? If you just do a little bit further investigation, secant of 30 is equal to cosecant of 60. So what's going on here? Well, let's take a look at a 30, 60, 90 right triangle. And this might not be exactly 30, 60, 90, but let's just go with it. So here's 30, here's 60. And let's just, for the time being, I'm not going to get values out there on this triangle except to say, let's call this one A, let's call this one B, and let's call this one C. I know that's like really imaginative. Where in the world did you come up with that stuff? So we'll just use A, B, and C like typical right triangle legs and hypotenuse. And let's look at the sine of 30 degrees for a minute. Okay, sine of 30 degrees is equal to opposite over hypotenuse. So in other words, the opposite of 30 is A. So that's opposite, and that's supposed to be a degree symbol. Opposite over hypotenuse, which is C. Okay. And then we know that that was equal to, from the previous slide, we know that that was equal to the cosine of 60. So let's look at the cosine of 60 and see what we get. Well, cosine of 60 is going to be adjacent over hypotenuse. So if I look at 60 degrees, A is adjacent, so that's adjacent over the hypotenuse C. So that's where this relationship comes from. We get that the cosine of 60, let me rearrange this really quick. We get that the cosine of 60, by virtue of this relationship here, A over C, that's equal to the sine of 30. And that's why, if you look at this triangle. And if you do some further investigation, you can just hit pause here and do some yourself. Look at the tangent of 30. Okay, the tangent of 30 degrees was the same as cotangent. Well, if I look at the tangent of 30, Tangent of 30 is opposite over adjacent. And then if you take the cotangent of 60, that's adjacent over opposite, or A over B in both cases. So that leads us to this theorem called the complementary angle theorem, which is cofunctions of complementary angles are equal. And by complementary, we're talking about two angles, you know, not like, oh, I really like your shoes. No, you have a great hat. That's not like complement. Complement meaning the two angles, let's call them, oh, I shouldn't have used the small letters. Those are for sides. Like we'll say angle A plus angle B is equal to 90 degrees. And if you remember this back from geometry, there was complementary and then there was supplementary. So we're talking about complementary angles, two angles that add up to 90 degrees. Cofunctions are, the cofunctions of those angles are equal. So the cofunction angles would be like sine and cosine would be related to one another, right? We already saw that, sine and cosine. And then cotangent and tangent. And finally, secant and cosecant. Okay. So just one to think of really quick for yourself. If I have a sine of 35, then what is that equal to the cosine of? Well, I know that the second angle needs to add up to 90. So why don't you just take a moment and think about that. You can pause it here and do your own work. But if the second angle should add up to 90, then that means that the sine of 35 degrees should be equal to the cosine of what would end up being, oh, not 55, sorry, but what would be the cosine of 55 degrees. Okay, and we can just grab a calculator and check our work, and we'll take the sine of 35, and I'm in degree mode here, so I get 0.57, and then I'll take the cosine of 55, and I should get the same thing, and I do. So that works just like we expected it to. So now let's take a look at some right triangle trigonometry. See, the neat thing is now that I have the trig behind me, I can go ahead and solve a triangle like this. And when I say solve a triangle, I'm talking about figuring out the values of all the legs of the hypotenuse and all the angles. So if I look at this triangle, it looks like I'm missing this side and the hypotenuse and one of the angles. So what do I know about triangles that could help me? Well, let's see. I've got all my trig functions, right? I've got sine and cosine and tangent. Those can all help me. And what else? Right triangle. I also know this. I know that a squared plus b squared is c squared, which is Pythagorean theorem. And then finally, I also know that the angles, I'll just write, the angle should be equal to 180 degrees. Okay, so these are all the things that I could use to help me figure out the missing values in this triangle. So let's try to pick out the easy ones to attack first. Well, looking at what I've got, I'm pretty sure that I can't use the Pythagorean theorem because I'm still missing a and c. But I could use the idea that all the angles add up to 180 to figure out the value of b. Right, b's the only missing angle. So that means if I take 35 plus 90, and if I get, let's see, 125 out of that, then angle B should help that add up to 180, right? When I add B to get 180. And just some simple math there will tell me that angle B is equal to 55 degrees.